All right, welcome. So this is our Identify Stoichiometry lab. So I'm going to run through and get your data, and I'm going to walk you through some of the calculations too. Okay? All right, so what you should have, I'm going to go ahead and show you printed. If you don't have it yet, you need to get it off Google Classroom, or you can set up your notebook, okay? Is this Identify through Stoichiometry lab, or you can set up your notebook as it's pictured there, okay? But one of the things we're going to walk through is kind of talk about what we're going to do. All right, so let me go ahead and bring you a little closer to our lab sheet here. Okay, so you should have your lab sheet. So here is our lab sheet. It's from Classroom. So if you didn't know where it was, if you haven't printed it, it's sitting here on Classroom right here under Unit 5, Identify through Stoichiometry Lab. Okay, and here is our worksheet. I'm going to bring it a little closer so we can actually see it together. All right, so here's our worksheet. It says in this lab you will be able to calculate and estimate how many grams of CO2 that you should be able to make with a known amount of baking soda and vinegar. The overall reaction, notice this says overall reaction, you will see is this. And this right here I'm going to put underneath here. I'm going to put what each one of these are, okay? And so we're going to make it a little bit, we're going to put in here, this NaHCO3, that is your sodium bicarbonate, okay? And you're going to add to it here, this is your acetic acid, okay? And it's going to yield, okay? It's going to yield, as it says above, sodium acetate plus water plus carbon dioxide. So this is just the word formula here. So sodium bicarbonate plus acetic acid yields sodium acetate plus water and CO2. Okay. All right. Now we're going to go down to our procedure. So in our procedure, I've already done this. I've taken out my weighing dish and placed it on the scale and pressed 0, and I weighed out 8.0 grams of sodium bicarbonate. And then I measured out 40 milliliters of acetic acid in my graduated cylinder. And now what you're going to see in just a second when I get you guys up here is I have placed my Erlenmeyer flask on the scale and pressed 0. In your data table, you should have already put sodium bicarbonate. It says up there we weighed out 8.0 grams. And acetic acid, when I pour it into the Erlenmeyer flask, we're going to take that measurement as well. So let's go ahead and head to our experiment. Okay. Okay, so here's our experiment, and we have our flask on here. Hopefully you should be able, it's not glaring. You have your mass here, and we have what we measured here. So I'm going to go ahead, put that in there. I've zeroed it out so we're not measuring the mass of the flask. Pour that in there. And I'm going to take, this is the mass of acetic acid that I'm starting with. And so in your data table for acetic acid, you're going to write 39.9 grams, okay? And then let's look at that for just a second. So if we look at it and we add in 39.9 grams, we're going to say the before reaction. And so the before reaction is going to be, right, we're going to add our sodium bicarbonate to our acetic acid. So how would I get that reaction mass? What would I do with the two numbers above when I'm going to put them together to get the total mass? So I'm going to leave that before reaction for you to calculate. What would I do with those two numbers just above? Now we're going to do the reaction, and you're going to record the after reaction mass, okay? And so let's go ahead and go on back to that mass. There it is, okay? So we have our 39.9 grams. I have my 8 grams of sodium bicarbonate. I'm going to go ahead and add that in. Okay, and you can see there's bubbles. So what? And that's a gas that's making all those bubbles. So what is the gas that is a product? Hopefully you see that it's CO2. And what's happening to our CO2? Is it staying or is it leaving? Okay? And if it's leaving, what do you think is going to happen to my overall mass that I'm going to end with? If we're losing atoms, what's going to happen to my mass? So we're going to let this kind of react here, okay? And we're going to swirl it because I'm going to get all those little bubbles pop that had CO2 because we have an open system here, right? We have an open system that's allowing our CO2 to escape. And then we're left with whatever we have left. So we can see that the reaction has kind of calmed down. It's actually stopping. Okay, all together. And it looks like our end mass, our end reaction mass will be 47.0. So go back to your lab sheet, okay, and you're going to press in. What we ended with was 47.0 grams, okay? You should see a change in mass. And so then you're going to head down to questions 1, 2, 3. And you're going to do what is the overall reaction that occurred. So the overall reaction that occurred, I gave to you right up here. So this is my overall reaction. You're just going to copy that down for number 2, or number 1. Then you're going to balance the overall reaction, okay, here. And then you're going to answer number 3. What changed the mass of the flask in the after reaction mass? What was lost? What came out? What bubbled out and went out of the flask, okay? Then what you're going to have to do here is what mass of CO2 or carbon dioxide was formed. Well, think about what changed the mass of flask. What would you do this before reaction and after reaction? What would you do with those numbers, okay, to figure out the mass? Then number 5, it says, what is the balance reaction for the double replacement reaction for sodium bicarbonate and acetic acid? Notice when you look at the overall reaction, we have 2 compounds. So those 2 compounds create that double replacement reaction. And so you already balanced it. You're just going to copy it back down what you wrote in number 2. Number 6 is you're going to take the moles of sodium. You're going to figure out the moles of sodium bicarbonate. And so one of the things that you're going to have to remember I said you can't move them, or you can't forget them. You know what the mass is of sodium bicarbonate that you had, right? You know what the mass is that we started with, and that was, we started with 8 grams. So you will take 8 grams. I'm going to show you this one. The rest of them you're going to have to do on your own. 8 grams, okay, of the sodium bicarbonate. And you're going to multiply, if we look on our mole map, and I'm going to show you our mole map right here. Okay. Our mole map here, remember, when we look at our mole map that's in your book, when we start with mass, we're going to follow our map to the mole, and we're going to multiply by 1 over the molar mass. Okay? So if we multiply by 1 over the molar mass, okay, on here, we're going to multiply by 1 mole. Okay, and on the bottom, we're going to place the molar mass of sodium bicarbonate. If you do not remember how to calculate molar mass, then what I'm going to say to you is go back and review that in your book, okay? And also, you can also watch some of the videos off of my website that talks about molar mass. You also have your molar mass worksheet in your notebook, okay? Or you can come see me. The next one I'm going to actually do for you, because the moles of acetic acid you will not be able to calculate because we have not covered that yet. And so when we're talking about acetic acid has a mass of water plus acetic acid. So we only want the moles of acetic acid because that's what's going to react. So that is, when we're talking about a solution, is the molarity. And molarity equals number of moles over 1 liter, okay? And we actually were measuring in milliliters, so this 1 liter can also be written as 1,000 milliliters. So when we're calculating this, we're going to use, we know that the molarity of acetic acid, okay, molarity of acetic acid, of the acetic acid is 0.839 molarity, which means it has 0.839 moles of acetic acid per 1,000 milliliters. So when we set this up, we will start with how much we use. So we use 40 milliliters. That's how much I grabbed. Times, and our conversion is what we're going to use right here. There was 0.839 moles, okay, in 1,000 milliliters, okay? And so that is our conversion. I'll underline this so you can see. Okay, and then what happens is milliliters will cancel, milliliters on top and bottom, and what we will do is we will get an equal. So you will do 40 times 0.839, because it's on top, divided by 1,000. And you should get, this one should be 0.03356 moles of acetic acid. Okay, so now I reacted however many I started. You should get a number here, and 0.033. Now remember, in our s'mores lab, the limiting reactant is the one that we ran out of first, right? It was the one that stopped us from making any more. So the way we do it here in chemistry is we use those moles. That means we run out of the atoms. Remember, there's 6.02 times 10 to the 23rd atoms in 1 mole. So you will compare 6 and 7. For number 8, compare number 6 and number 7. And the one with the lowest moles is your limiting reactant. It is the one that stops the reaction, okay? Because once we run out, it's all over. Then you're going to calculate number 10. How many moles of CO2 did you make? Well, you calculated in number 4. The mass of CO2 is formed, so you should be able to take it to moles. And that will be your experimental yield. In number 10, where from your balance equation, you should have made 1 mole of CO2 for every 1 mole of sodium bicarbonate. That is by our balance reaction, which you did on number 2. Based on how many moles of sodium bicarbonate you started with, how many moles of CO2 should you have made? Well, remember, our limiting is here. So you're going to start with your limiting reactant. So the moles of your limiting that you calculated. And you're going to multiply by, you had 1, from our balance reaction, you're going to have 1 mole of CO2 over what's going to make 1 mole of your limiting, okay? And it's because it's all a 1-to-1. Hopefully you already know as you got there that it's already balanced, okay? And you're going to calculate how much CO2 you should be made. Then you're going to do number 11. You're going to be accepted minus experimental over accepted times 7. And then think about what could have made that experimental error go higher. Now, on some of these you may be confused, so please come see Mrs. V, and I will help you through this, okay? And help you get those calculations and to help remind you of how to do those mole conversions, okay? So, okay, that is our lab. If you have any questions of how to do the calculations, please let me know. Please come see me and I'd be happy to help you. Other than that, I'll see you later.